Let's talk about adding radical expressions. Radical expressions are expressions that have radical parts to them. We have three radical expressions that we're adding and subtracting here. We have 5 squared root of 8 minus 3 squared root of 18 plus 4 square root of 32. The first thing you might be hoping is, well, can we add the stuff inside the square roots together in some way? We're not allowed to do that in any way. We can't add stuff between square roots. In fact, let's take a step back and let's look at a more simple example. Before we continue any further, we need to talk about adding radical expressions together. First of all, what you may hope is that adding radical expressions is the same as multiplying radical expressions. When we multiply two radical expressions that have the same index, like two square roots here, we multiply the radicands, or these expressions under the radical, to be 3 times 5 is 15. So we multiply these two together, we get the square root of 15. The hope that you probably have is that, well, then we can add in the same way. Well, if you've got this far in mathematics, you'll probably know that addition is rarely easy, of fractions, of expressions of any type. In this case, we cannot, as you may hope, we cannot add the radicands together, the 3 plus the 5, to get the square root of 8 in this case. That is not true. So the question becomes, how can we add these types of expressions together? As with everything in mathematics, every new technique or concept has to be built on previous concepts. Let's take these two radical expressions right here. I have 2 times the square root of 3 plus 7 times the square root of 3. We can add these together, and I'll show you how, but I won't use the actual property of adding them together. What I will do here first is I'm going to factor out of these two terms the square root of 3. In this new expression right here that's equivalent, what I've done is factored out these factors of square root of 3 in each of these cases. That's a legit move. That's just factoring out a common factor. But now when I look at this, the order of operations say that I can add these two numbers, the 2 and the 7, together, giving us 9 times the square root of 3. So the question becomes, what can we do? How did we do this? We have simplified these two separate expressions into one. And what we did was we treated these just like any other algebraic expression with variables, where we have the coefficients and the variable parts. If the variable parts are exactly the same, we can add their coefficients. In this case right here, if we have 2 square root 3's and we're adding 7 more square root 3's, we can add these coefficients of 2 and 7 together to get 9 square root 3's. The important part of this conversation is that the square roots must be the same. Before we continue with the other example, I really want to hit this fact, is that anytime you add or subtract any kind of mathematical objects expressions, you have to have the same type. For radical expressions, the radical must be exactly the same, and then you can add these multiples or the coefficients out front. All right, so we can combine radical terms as long as they're of the same type. Well, that doesn't help us very much here. We have a square root of 8, a square root of 18, and a square root of 32. Here comes the important trick. What we can do is simplify each of these radical terms first. Here I am getting ready to reduce each of these. What I did was I factored each of these radicands inside the square root to get my greatest perfect square factor. Now what I'm going to do is split this radical up and apply the square root to that perfect square factor to get it outside of the radical. So when I take the square root of the 4, I get a 2 on the outside of the square root here. The 9 becomes a 3 and the 16 becomes the 4. I'm just going to clean up these multiplications on the outside. I get 5 times 2 is 10 root 2 minus 9 root 2 plus 16 square root of 2. Now, in a beautiful way, I can look at this. These are actually all like terms. This question was set up like that. But now I have 10 square root of 2's minus 9 square root of 2's plus 16 more square root of 2's. 10 minus 9 is 1 plus 16 is 17, giving me a final answer of 17 square root 2's. That is my final simplified sum of these expressions.